Today is the day that you've been waiting for. I promise. I promise. The reason you took this class was for today. Hey? Finally! We get to start training. Woo! I love this day.
What have you been doing?
We've been doing algebra.
Oh, okay.
Yeah. Now we go. Now we do the trig. And the trig is sheer awesomeness. I love trig. Love it. Love it, love it, love it. Okay? So, we're going to be talking about trig functions. Okay? A trig function has an angle measure as its input. So the angle now is the independent variable. And the output, the dependent variable, is a real number. Okay? So we're going to input angle measures, we're going to output real numbers. Okay? Love it. Love every part of it. Give me a couple of seconds to finish writing down that slide. So, we're going to talk, because we're talking about angles, we got to talk about different units. Okay? So the unit that we are going to use is degrees. Okay? Or for a little bit we'll use degrees. Really, when we get into higher level trig, which we'll get into higher level trig in about 5 minutes. Okay, so we don't spend very much time on the baby steps. We go, man. Let's go. Okay, so degrees are great and all. Okay, and so the distance around a circle, or I shouldn't say the distance around a circle. Excuse me, pardon me. The angle degrees around a circle is 360 degrees. If you go all the way around a circle, anybody know why it's 360 degrees? Anybody? Because somebody didn't like people or something like that, or somebody just randomly chose it. Okay. It's a base 60 counting system. And the reason that it's a base 60 counting system is because so many numbers can go into 60. Okay. Relatively nicely. Okay. So if you think about it, if you think about numbers that can go into 60, 1, 2, 3, 4, 5, 6, 8, because that would be a relatively easy one. Okay. Where it's going to be 8 is what, 7.5 when it goes into 60? So it's not bad. 9 is not bad. 10, 12, 15, 18, okay, 20, 25, 24 for sure. Okay, lots and lots of numbers go into that, which means we can divide up our circle into lots of different chunks. Okay? What we're going to be doing probably starting next week, is we're going to start developing the unit circle again. Now, you've developed the unit circle a little bit in Algebra 2, okay? But we're going to take that to the next level, okay? We're going to utilize the unit circle pretty much every day from now until the end of the class. I should say now because we haven't developed it yet, but so starting next week, we're going to use unit circle a lot. Okay? You're gonna wear out unit circle pages because we have unit circle pages. We've got purple half sheet ones. We've got goldenrod half sheet ones. We've got light purple full ones. We've got goldenrod full ones, green full ones, because you go through them so much that we just keep having to give them to you because, like last year, we found that the people were using them so much that the ink was actually wearing off of the paper from the copies because we were using them so much. So, okay, so we're going to use them a lot. Okay, so let's talk about a circle just in general and angle measures on it. Okay, now one thing that you should know in trig, 0 is over here. Okay? That's where 0 degrees is at in trig. It'll be confusing when we get into about March or April-ish when we start doing some navigation type things, because then with navigation, 0 changes to up top. North is 0 degrees. Okay, so that's going to be a little confusing, but we'll work our way through it when we get to that. Okay. What other degree measures could we also put on there? Where's 180 degrees? So straight out to the left? Because if we divide the circle in half, we just said that there's 360 degrees around the circle, so if we divide that in half, that'd be 180. What other ones?
90.
Where? Straight up. Okay, straight up would be 90. Where? 240 at the bottom?
No.
270 at the bottom, yep. Brother? 360? Yep. Coming back to 0? Where? Halfway between 90 and 0 is 45. Halfway between 90 and 180 is 135. 225 is halfway between 180 and 270. 315. Halfway between there and there. Yeah, love it. Love it. Okay. Just when you thought, what's up?
Does it matter, like, which side the 90 and the 270 are on? Or
Yes, it does.
Okay.
Yep, it does. Because here, I'll show you what. In trig, we go counterclockwise. So we have this labeled for trig. And so if you're thinking, well, what if I want to put my 90 on the bottom? Okay, which would be fine. But then, that's where I was just about to say, I'm going to blow your minds now. But then if I want to put 90 down here, that is actually negative 90 degrees is down there. And this one could be negative 180 degrees. And this could be negative 270 degrees if I decide to go in the opposite direction. Okay. Which would also make all of these negative 45, negative 135, negative 225, negative 315, so on and so forth. What do you notice about the positives and the negatives? Go ahead. No, you got it. Right, but if you go, because when we go positive in trig, that direction is positive, and this direction is negative, right? So since it's 360 all the way around, halfway is going to be the same positive or negative. Okay? Yep. If we go all the way around, negative 360 back to there, yep. Or 0. What do you notice about red and green numbers or red and blue numbers? Notice anything about it? Yeah, 360. If you ignore the negative sign, they add up to be 360 degrees. Always. Okay. Love it. What you need now is you need a blank sheet of paper. Preferably in a notebook. Okay? If you're using loose leaf, that's fine. Just make sure you put some extra paper underneath. Okay? Then, what you need is you need to come up to the front here. If you don't have an extra sheet of paper, I got extra sheets of paper for you, but it's easier if it's in your notebook. Leave it in. Yeah, leave it in, because then you got the backing. Okay? You'll need a ruler. You will need a compass, and if you hadn't picked up your Smarties yet, you need some Smarties. Okay? Alright? So everybody needs that. So everybody needs a ruler, a compass, and one thing of Smarties. Okay? Make it happen. Alright, so here's what I want you to do. I would like you to, in the center of your paper, okay, like center horizontally, center vertically, I would like you to put a dot right in the center of your piece of paper. Okay? I'm going to represent my dot with a dot. Pretty smart like that. Okay? Then, let's see if I can do this now. Tools, I want a insert. What do I want to insert? I want to insert. Where did my thingy go? It's in. Okay, then we needed that. Oh, I don't want that. I just had to find my compass. Okay? So, then, what I would like you to do is I would like you to draw yourself a line, straight line, from your dot directly out to one side. Straight out. I don't care which angle it goes at, but you're going to draw yourself a line. Longer. Yeah, you want to go out. You want to go out a ways. If you're going straight out to the one side, you would for sure want to go out all the way out. Now you're gonna take your Smarties. Don't eat them yet. Okay, not yet. You're gonna open them up. This is where the tricky part comes in because now you're gonna open up your Smarties, but you can't eat them. Okay. Right. And what I would like you to do is I would like you to put 7 Smarties reading mine. Because I got Smarties up here. Okay? So what I want you to do is I want you to put 7 Smarties on your line, edge to edge, 7 of them. God, these Smarties are good. Want to do like one of mine? I wouldn't give you the wet one, because apparently nobody likes it. Who was listening? Now, I would like you to make a mark at the end of your 7 Smarties. That's your radius. Okay? So you can move your Smarties. Now, still don't eat them. Still don't eat them. Unless your name is Linsmeyer. No. Okay? So now, draw yourself a circle. I gotta go back to like green here. Draw yourself a circle. Oh, come on now.
I'm so bad.
Oh, come on. Open up. There you go.
Oh no, oh no, oh no. Okay, I messed something up. My circle did not close.
Oh, snap. Now remember, easiest way to use these, okay, this pointy thing at the top here, this plastic piece, that's what you use. Okay, that's your spinner. Okay? And the reason that I had you put paper underneath is because then the claw, I call that the pointy part, the claw, that sticks in more. Okay? So don't be grabbing both sides as you're going around. Okay? Get yourself and then plant it and then draw it with using the top. Because what happens is if you grab onto both sides as you go around, you're gonna increase the width of your circle and then it's not gonna close. Not saying seen it 1,000 times. Nope. Your name's not Lynn. Okay?
Grab right here.
Grab right up there. Yep, grab up there.
This little thingy.
Yeah, nope, grab up top. Alright? Now,
Like
get it out of your mouth. You need them.
Wait, what?
You cannot eat your Smarties yet.
I may have ate one.
Yeah, we're not done using them yet.
I didn't eat them.
Oh, I'm just saying. Okay? Alright, so now, I would start, if it were me, I would start where my line or the original line segment that I drew, that radius, intersects the circle. Okay, that's where I would start. But what I would like you to do now is, I don't know why I was going to put this one back in my tray. Okay, what I would like you to do now is, I would like you to start with one Smartie on the circle at the line, and then go in groups of 7 Smarties.
Doesn't matter which way we go.
Nope, doesn't matter which way you go. After every group of 7, put a mark. It's just your compass. Okay. So after every group of 7, put a mark. Edge to edge. Okay. How many sections did you just divide your circle into? Nope. Count them up. So I got 1 section here, 2 here, 3 there, 4 there, 5 there, 6 there, and then I got a little extra chunk, right? Okay? And depending upon how accurate you were, it should be right, whoa, tap the brakes. It should be right around 2 Smarties to go in there, right? 2.5, okay? Depends. It really depends on, like, sometimes your Smartie gets, you know, like your Smartie got scrunched a little bit there on that one, you know, okay? So it kind of depends on the Smartiness there, but it should be right around 6 sections. Okay, plus 2 extra Smarties. Okay. Now, each section was how many Smarties long? 7. What was the radius again? 7. Okay. Alright. It's kind of weird. It's what? It's called a radian. Okay? What's a radian? It's like the radius, right? Okay? So, what we just came up with is we just described, and I'll put it in Smarty Pink. Oops, up here. Yeah. What we found is we found that this angle here is 1 radian. A radian is the angle needed to travel the distance. Oops, I don't know why I was going with S there. The distance of 1. Oops, let me put that in a different color so it pops. the distance of one radius, the angle needed to travel the distance of one radius on the circle. Side note, the symbol for a circle, if you don't want to write out the word circle, oops, that's a bad one. Dropping everything today. Too many Smarties. Symbol for a circle is an O with a dot in the middle. Okay. So what that's saying is that if I go back up here to my sections, so this distance right here is equal to 1 radius. So my radius was 7 Smarties in this case. My distance between those marks that I made is always 7 Smarties. Those distances are equal. Now, why didn't it work out perfectly? Why didn't it come out to be 6 exact?
Because the sides of the circle aren't like straight lines with edges, it's like curved lines.
Okay.
So it's not a perfect 7 every single time.
Okay. Thinking about your trigonometric knowledge, what else comes into play? 360 divided by 7. 7 is the one number that's not even, or that doesn't go into 60, right? Okay. Right. What else? What do you got? Pi comes into play. Okay. Right? Plus, it's the season of pi. When I think of fall, I think of pies. Okay? Alright? Not only because that's when we start teaching trig, but because you got pumpkin coming up. It's a great time to make apple pie. What stops with apple pies? Because I'm talking about food and yet there's still Smarties sitting in front of you just taunting you. Still taunting? Still taunting? Alright, go ahead. Okay? Alright? So, the distance, so the other, okay, I gotta get one more slide. Okay? So the other measure that we use, and remember how I said we'd get to higher level trig? Well, we just developed higher level trig. Okay? The other one is radians. Okay? 1 radian is approximately, okay? Now if I were to, let me see if I can remember how to do this now. Here, there, actually let's be smart about this. Let's do it this way. Spin, spin, open, rotate, mark, be gone. Okay? So this distance, or this angle measure, I should say, let's go blue on it.
Smarties do have flavor.
Smarties do have flavor.
Yeah, we're testing the flavor.
Green,
right
you
now.
can really tell a difference.
Love it. I don't know why this extra theta is sitting over here. We'll get rid of that theta. Okay? So that angle measure, now let me see if I can get it protract. Oh, there it is. Wow. that angle measure is somewhere below 60 degrees, right? Okay. So this angle is what, whoa, tap the brakes. Kind of jumped around. Let's get rid of this. Just, drop it like it's hot. Oh, I watched him earlier this week. Okay. So theta right there, okay, is, so this is my radius, this is my arc length, S, we call arc length S. Sometimes we put a little fancy S on it to make sure it doesn't look like a 5, okay. So my arc length S is equal to my radius, which means that theta is 1 radian, which is approximately 57.2958 degrees. All the way around a circle is how many radians?
6.28.
Okay, so it'd be 6.28 radians all the way around, right? Which is what in terms of pi? It's 2 pi. Yep, it's 2 pi. So 360 degrees is equal to 2 pi. Actually, I'll just go right to it. 2 pi radians. The symbol for a radian is, instead of the degree symbol, it's an R. Yeah, it's a symbol for a radian. Now, going forward, calculating this stuff, calculating out radians and all that fun stuff, okay? So that is going to then tell us we need to know what mode our calculator is in if we are using one. Okay? And so, dependent upon which calculator you're using, scientifical type calculators usually have an R or a D or a DEG or an RAD somewhere in the display. On the TI Inspire calculators, it's actually up in the upper right-hand corner. It'll either say RAD or it'll say DEG. Okay, so you've got to be aware of that. You need to be cognizant of it because your calculations are going to be different based upon which mode you're in. Okay? I think there's some more stuff way down here, but way down here, how many degrees is 1 radian equal? We already did that. About how many radians does it make to make a complete revolution? We also already did that. Okay? So, how many radians for 1 complete revolution? We just talked about that, 2 pi. We're going to hammer that point home. Okay? So, 2 pi radians makes 1 complete revolution. Which was 360 degrees, correct? Is that a reducible fraction? Pi, just pi, right? Because R is the label, if you will, yeah. Okay, so just pi over 180. Okay. Now, that, put a definite star by that, because that, ladies and gentlemen, is how you convert betwixt the two of them. Okay? So if you are going from degrees into radians, you are going to multiply by pi over 180. Because your degrees then are going to cancel out. If you had 78 degrees, you multiply it by pi over 180, now you're in radians. If you are going from radians into degrees, what are you going to multiply by? No. 180 over pi, yep. You're going to flip that around. And we will be doing a lot of this conversion starting tomorrow. Okay? Converting back and forth between radians and degrees. Okay? They are not the same. 45 degrees is not 45 radians. Okay? Okay? They are very much different, and depending upon the calculator, when we get into sines, cosines, tangents, cotangents, cosecants, and secants, we'll see that they're very much different depending upon degrees or radians that you get. Okay? Two things before we wrap it up here in the last 6 minutes of class. One, make sure your Smarty wrappers make it into the trash and not onto the floor. Leave the area better than you found it. Two, make sure compasses, protractors, and rulers all get back up into the appropriate spot. Okay? I be done. Happy Trig Day. Happy Trig.